Welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi, NCR. St. Andrew's Institute of Technology and Management is located in a very picturesque, neat, and clean surroundings, away from the noise of the city and still very easily approachable. This is one of the best college in the entire country. St. Andrews provides best quality education at best prices. It is one of the great career choice that you will make for yourself. It has n number of benefits. It provides 100% job placement and job assistant. It provides a variety of courses to choose from like BTech, BBA, BCA, and they are soon starting up with MBA, architecture and law. Here we discuss the subject Mathematical Foundations of Computer Science. Code is BCA 108 and this is in accordance to BCA second semester syllabus that is affiliated to MDU University Rohtak. We discuss the topic graphs, types of graphs and vertex from second unit, and I Shalini from the BCA department shall be taking you forward. Graph. A graph is a non-linear data structure consisting of nodes and edges, right? So what you have nodes and you have edges. And what kind of data structure? Non-linear kind of data structure. The nodes are sometimes also referred to as vertices. So the nodes are known as the vertices and the edges, that is the lines that connect any two nodes, are the edge, right? So nodes are called the vertex and the lines connecting the node to two nodes are called the edges, right? So a graph consists of a finite set of vertices and a set of edges which connect a pair of nodes. So your this 0, 1, 2, 3, 4 are all vertex and the line connecting these are the edges. So 0, 4 is an edge, 0, 1 is an edge, 1, 3 is an edge, 1, 2 is an edge, 3, 2 is an edge, right? Right. So in this graph the set of vertices 0 1 2 3 4, so 1 2 3 4, and edge is 0 1 1 2 like we discussed now. So all these are edges. Graphs are used to solve many real life problems. Okay, now where your graphs are used for? So graphs are very beneficial in representing networks. The networks may include paths in the city or in telephone network or circuit network, and they're also used in social networks like LinkedIn and Facebook. So the Facebook, like each represented as a vertex and the connectivity is via an edges, right? So each node will have a structure and it will have all the information. What are the information will have? The person's ID, the name, the gender, the locale, right? See, whenever you put anything on the Facebook and you write your name, you have to search for in the URL, it shows something else. So maybe that's your Facebook person ID, right? It's a node and it stores all your information. It's in a structure form, right? That is your name, your gender, your location, your profiles, everything is being stored in there, right? So that is the practical implementation of a graph. The next topic we have is types of graphs, right? Undirected graph. What is an undirected graph? That is which do not have any direction. In an undirected graph, the orders of vertices in the pair in the edges set doesn't matter. Like 4 5 means 5 4, right? Thus, if we view the sample graph above, we could have written that as 4 6 4 5 3 4 3 2 2 5 1 2 1 5, right? So you can write it in any way. An undirected graph, they are usually drawn with straight lines between the vertex. The adjacency relation is symmetric in nature. So u to v is the case v to u. See, if we see in this our graph, so our 0 4 and 4 0 is same. 0 1 1 0 means the same in an undirected graph. There is no arrow in between. That is why it is undirected, right? And indirected, the direction will matter, right? So in a directed graph, the order of the vertices in the pairs in the edges matter. Thus u is adjacent to v only if the pair u comma v is in the edge set, right? So if u comma v is in the edge set, so for directed graph we usually have arrows or arcs between vertex. An arrow from u to v is drawn only if u comma v is in the edge set. So we look it here. See how many parts it has. It's at vertex set A, B, C, D, E. So that has a vertex set. It has an edge set A, B is there, but B, A is not there, right? So B, C is there, C, B is not there. Now CD is not there, you have DC, right? And you have B to D also and D to B also, so DB and BD both you have. And this you have BE you have, and ED you have, right? So BD and DB, this is an arrow in both the direction. This is the common one, you please note it down. Okay. Then you have vertex labeled latch graph. So in this, and each vertex is labeled with some data in addition to the data that identifies the vertex. So just as you have ID, you also have along with it some other information. So like if this is a similar to key comma satellite data distinction for sorting. So like if I have this color coded, like see, look at this figure, 3 2 6 4 5 so 7. So the underlying set of keys are the vertex. The data side data, satellite data, your color represents one, the satellite, so 2 and 4 would be the same, right? So this is for the identification purpose, the ID that this is one. But 5 and 6 will belong to the same satellite. 3 is different, 2 4 is same, 7 is different. So you have how many types? 1 2 3 4, right? You have 4 types in this, in the total of 1 2 3 4 5 6 vertex you have. So the underlying set for that satellite data is the color. The key is of course the number that is written there. So 2 comma blue, 4 comma blue, 5 comma red, 7 comma green, 6 comma red, 3 comma yellow, right? And you have an edge set 2 4 2 2 4 4 2 5. So the edge set doesn't have any difference, only the vertex will have. It will have how many data? It will have 2 data. So if you're representing the vertex, it will be this 2 comma 5 where blue is 1, so 2 comma blue, look at here, it's 1. Then you'll have 4 comma blue, similarly you have 3 comma yellow, so 3 comma yellow is there, 7 green, 5 red, 6 red. So this is how it is being represented. I hope it's clear to you. So this is vertex labeled. Okay, now cyclic graph. So cyclic graphs are one with at least one cycle is there. So if you have any one cycle from the edge to itself, so you will have, see, 2 to 4 is there. From 2 that goes to 4, 4 to 5, 5 to 7, 7 to 6, again to 2. So again from 2 it comes back to 2 with any number of edges in between. So if it forms a complete cycle, at least one cycle is there, it's a cyclic graph. Then you have edge label graph. What's an edge label graph? An edge label graph is a graph where edges are associated with labels. So your each edge will have a label in it. Like, so we can indicate by making a set of triples like u comma v comma x, right? So there's an edge from u to v, there's an edge, and with the label is there on that, that is x, right? So your uv at vertex and x is the label on that. So edge label graphs, these are usually drawn with the labels drawn adjacent to the arc specifying the edges. So see in this color, the next figure, red, green, white, blue, green, you have this graph is there. You have 4 vertex with 4 different coloring, so it is vertex labeled also, and it is at label. So like red to green, it's the information is going white comma green. From white to this red direction it is blue. So each edge is labeled differently, right? So it is here, the, so see, you have the vertex at red green blue white, you did there, red green blue white is there, and the edge set is red white comma white green. So this red white will have white green. So red is one vertex, white is one vertex, and white green is the edge. So this is representing this red, this white, and this edge. So it is in here red white and white green. So this is how you label it with the help of an edge, right? So similarly you will be drawing for each and every, you will say, so you will say white, you can say white, sorry, where is gone, white, red, and then you will again write blue in here, so that it becomes edge label. So what is the label? Blue is the label, right? And your u is white and your v is red, and your label is, your x part is blue part. See, so simple and easy now. You should not get confused, it's very simple. Okay, what's a weighted graph? A weighted graph is an edge label graph where the labels can be operated on by the usual arithmetic operators, including comparisons like using less than and greater than. You will have this. So weighted graphs are already used for comparison because you have to see the shortest cost to reaching any destination. So your weighted graph will actually help you find the shortest cost, but because that is what they are being used for, right? The way the weights that are there, it will really help you from one destination to other in reaching. So here one, what are the vertex? 1 2 3 4 5 are the vertex, and then this edge set. So 1 to 4 has 5, and 4 to 5 has 58. 1 to, sorry, 1 to 2 has 2, 2 to 4 has 5. So this is how it is being done, right? From 4 to 2 it will also be 5. So now you see the weight in the graph. What's the weight? So you can always compare with the hell, like which is the shortest. So if you have to reach 5 from 1, so 1 to 2 and 2 to 5 is one pass. So 2 plus 4 is 6. Then there's this 5. You go 1 to 4 5, 4 to 2 5, 5 5 10, and then this again 2 to 5. So you'll have 10 10, 5 5 10, and 4 15. Then there's this one path which is the longer. There's 1 to 4 is 5, 4 to 5 is 58. So it is useless to go this way. So you go from 1 to 2 to 5. That is the shortest. So you, there's 2 and it is 6. This is how you do. Okay. Similarly, see, if you have to go to 3 to 5, so there is one direct graph that is 34, and there is one where you can go by 2. So you go with the cost of 14 to 2. So from 3 to you reach 2 by 14, and then you, again you reach 4. The 14 plus 4 becomes 18, right? So this is shortest. If you rather than going directly from 3 to 5, you can go from 3 to 2, and then 2 to 5. So here your weight comes into considerable kind of that is effect onto your algorithms or anything that your structure that you are using. Okay, then there's this directed acyclic graph. See, in it is also known as DAG. It is a directed graph without cycles, right? So they appear special cases in CS applications all the time. See, there's no cycle in there. See, it appears like it's a cycle, but it's not cycle. It is close. It appears like 1 from 2 5. It doesn't form any kind of cycle. So it is directed acyclic, direction plus without any cycle, right? So you are following vertex 1 2 3 4 5 6 7 8, and you have edge set 1 2 7, 7 to 2, 2 to 6, 6 to 8, and 7 to 8, 5 to 4, 5 to 2, 3 to 5, and 3 to 1, right? Okay, then this comes disconnected graph, the last one. See, if any two vertex in the graph they are not connected, then it becomes disconnected. Any two vertexes they are not connected. So if this is two, this is one graph and this is two graphs. So in here A, B, C, D are connected, E, F, G, H are connected, but C, E are not connected. So it becomes a disconnected graph because these two vertex are actually disconnected from each other, and there's no path that can actually go from one to another. So it is written all in this there, that vertex in a graph do not need to be connected to other vertex. It is length for a graph to have disconnected component, and even lone vertex without a single connection. So if it will be one single without any connection, then it also disconnected graph, right? If it contains at least two connected vertex, at least if any two vertex are there which are not connected, then it comes a disconnected graph. So it's an example of disconnected graph. See, we have written A, B, C, D, and E, F, G, H are vertex, and they are two independent, and there is no connection between them, the C and E part. So now it becomes disconnected, right? Okay, so we come to the important question: what is a graph? What are vertex and edges in graph, and what are the various types of graphs? So I hope it's clear to you. And for any doubt, you can always contact me. That's all for today. Thank you. All the best.